Welcome everyone. This is the third session in the prior to programming track, and it's the second to last session overall. So this is today's schedule. We'll have a recap of session 2 and followed by the 7th pathway in the exercise, the course. It's a pretty big pathway compared to the rest, so that's why I've planned it in one session itself instead of including another pathway like I usually would. So a small recap of last time. We talked about life cycles, which basically are stages. It's analogous to organism life cycles where a certain organism goes through certain stages in life. Each stage in the process having different properties, you could say, from birth to death. And similarly, each activity or each fragment in your app has its own life cycles. Whenever you start the app to whenever you exit, until you exit the app, you have a bunch of life cycles. It's not that when someone says an app has a life cycle, it's not that as a whole it has a life cycle. It's not that the app on a whole has its own life cycle. It's that rather what they refer to usually is that each activity or each fragment in the app has its own life cycle, and so in that sense you can say overall the app has a life cycle on its own. So that's what people refer to usually when they say apps have their own life cycles. And when they get down to more specifics, they might talk about a specific activity, but usually you can understand from the context itself that when they say life cycle of an app, they usually mean life cycle of the different fragments or activities contained in the app. And we took a look at logging as well, which is basically printing messages to one special tab you have set apart for you in your Android Studio called the log cat. And we talked about how there are different types of messages you can use for logging. You can filter out by class and messages. So you could filter out only the information messages in the main activity, or you could filter out all the error messages in another activity. And it's a very useful tool. And there's another tool called Timber, which essentially does the same thing, but it offers you a couple more features apart from the standard login library. And you can check that out. One thing, do remember, if you're going to use that, you have to export it, import it from the GitHub link. It's in a third-party library and it does not come inbuilt with your standard Android Studio code. Then we looked at app architecture, which was, I would say, the most important takeaway from last week's session. And it's basically a set of guidelines given by the people at Android to help you write better code. And it looks cleaner, it's just better to maintain. And we all know that when you're a programmer and you write code, it's more of reading you'll be doing rather than writing. So maybe you come back a couple of days later for the project and look at the code, instead of ending up pulling your hair out trying to figure out what you wrote and why you wrote it. If you follow this architecture and the following model, you might have a little easier time trying to read your code and getting yourself up to speed before continuing. And to help us write the better code, there are guidelines given by the Android people, and there are three different sets of guidelines, and we can follow whichever one we want depending on the needs. There are three set of guidelines, and they are three models, I should say, rather. Three ways or three templates in which you can model your app after to ensure you have all these benefits of ease of maintainability and readability. Three of them are quickly MVP, MVC, and MVVM. And we looked at MVVM last week, which is what's followed in most Android apps. Its expansion is model, view, model. And quickly, model is what gets your data for you, view model is what stores the data for you, and view is what uses the data to shows the data that you store, along with handling click lists for the UI components and displaying the UI components on screen. Personally, I worked with web development as well, and that is where you would see MVC, one of the other architectures or guidelines mentioned by the set of guidelines or architecture models mentioned by Android. And MVP, P stands for presenter, and you can think of it as a replacement for view model from MVVM. And if you want, you can explore those other two models on your own in your own time. But for Android, we'll be sticking to model view model. And this is actually the one of the better diagrams out there that helps you understand or probably get a better idea of how the MVVM architecture works. You might be wondering what this little repository in between is. Yeah, the repository acts like a middleman between the view model and the model, and it really offers no extra functionality in that you pretty much write the same things you write in model and repository when it comes to actual code, practicing code. If you look at your model class and your repository class, you'd find them identical except a few things here and there. And it's just to increase the layers or make sure you're more modular in that sense. And lastly, we'll do live data, which gives you real-time data updates from your app. Suppose, let's say, you are building a stock app, and we all know that stocks get updated every second, and you can't have the user, you can't give the user outdated data. Suppose you're having the stocks of a couple seconds back, you can't show them that, and then because they'll need the real-time information to make their purchase or investments or whatever. So in that sense, live data will help you in that whenever anything, the source of the data you're showing updates, you get a notification in your code, and based on notification, you can clearly load your UI or refresh your UI to make it seamless, and that you and make it seem like to the user that your app is always giving up-to-date data without causing you to perform any extra action. So let's get started with today's session. And today's session, like I mentioned before, the goal is pathway 7, and we'll be taking a look at the Codelabs that will eventually help you build the Track My Sleep app. And this is what it looks like. So basically, just quickly about the app, you can log your data for each day. You can rate the sleep quality. You can set the start time and then how many hours you slept. It will calculate based on the end time. And you can clear that all the data. You can store all the data. So that's really the main focus of today's session, which is storing data. Up till now, in all the past, I think 6 or 7 sessions, we haven't really touched upon storing data. It's just that we've shown data that we've created in the code itself. We didn't have any source of the data or any destination in the sense. So today that's all about to change. So let's get into it. We'll be focusing on the second unit and pathway 7 for today. So after today, you'll be able to store data locally for an Android app using something known as a room. You'll be able to handle long-running functions or functions that take time without locking or crashing the app with something called coroutines. You'll be able to display a list in an Android screen, and you'll be able to control button states based on live data or data values. So if the data value is, let's say, 0 or something, if you're tracking an integer, if it's 0, you can disable the button. If it's 1, you can enable the button, something of that along those lines. And we'll see how all this is done now. Let's look at the first part or the first set of concepts required for pathway 7. Right, so let's talk about databases, keeping all your apps data in one place. So quickly, for those of you who are unfamiliar or uneducated, databases is just a collection of information. That's all it is. But what makes it so special? Why do we have a separate name for it? Why can't we call it lists or just a collection? Why separate name databases? Well, because on the surface level, it might seem like it's a collection of information, but once you dive deep or go underneath the surface, you'll understand that databases give you much more than just random storage or just clumping information together. No matter which type of databases you look at, you'll always find some sort of neat collection or some type of organization between the data that makes it really easy to maintain, read, update, or even delete. With the help of databases, you can store data in common groups or similar groups, and you can really keep it safe and keep it in a faraway place without having to worry about what will happen to your database if something happens to the app or product. So that's all the kind of, again, this is all another concept of modularity, in that your database or your data for your app is completely separated from your app, apart from that one connection you'll have. And databases, like I said again, they store your data in an organized manner and keep everything nice and tidy for you. So like I mentioned before, there are certain types of databases. One of them is SQL, which stands for Structured Query Language. And in this type of databases, data is stored in tables. One One very obvious example, or something that jumps at me right away, is storing data in tables is student data. We all know AUMS. It's our portal for storing taking care of the quizzes and assignments. And you can imagine that the data they stored there would be consisting of the student ID, the student name, student grades per semester, SGPA, and the CGPA. So you can imagine that as a clear table with a fixed number of rows for every entry you put in or every record you create. So there'll be student ID, student name, student class, student semester, semester for CGP, semester for GPA for semester 1, GPA for semester 2, so on and so forth. So in that kind of situation, data stored in tables, and each table has its fixed number of rows for each entry, and there's a clear relationship among the data. As you can see in the example that I gave of the AMS table, you know that you can see that these fields or these rows that you put into the table, they are fixed. They have some relationship among them. They make sense that they're there. Suppose you want to calculate the marks or something, you can keep a marks table and only keep the stuff related to the marks. You wouldn't necessarily need the students section or the student semester to calculate the marks. So that would be unrelated data or useless data. So you wouldn't keep that. And in that sense, each table in SQL created with an SQL database has clear relationship among the data. And if you go into advanced SQL or research further, you'll see that you can have a relationship among different tables as well. And so there's a lot to go into SQL, but that's not the point of this course. So let's move on. Quite contradictory or quite opposite to SQL is another type of database, NoSQL, and it's not stored in tables. There's no defined structure of data. It's stored as you want. Maybe if you're familiar with JSON, you'll be understanding a bit better. Data is basically stored in JSON. That's a simplistic view of it, very simplistic view. Again, I'm not here to talk about that, so we'll move on. But if you want, I shall provide some useful links to get you started on all three of these databases. You can explore further if required. SQLite, which is what we'll be focusing on, or rather, in an indirect way, what we'll be focusing on is a lightweight version of SQL, and it's used in mobile devices. So on your Android device, there is data stored locally. Sorry about that. Uh, so like I was saying, SQLite is what we'll be focusing on. It's what is in there in your Android devices. This is where all the data for your installed app is stored, all your messages, your photos, and it's what we'll be focusing on for today's session. Room helping with storage. So I just mentioned SQLite, and there is a way to connect. There was a way to connect your Android app code to Room data or SQLite database in your app Android devices, but there were a lot of problems with that, and it was tedious to write code, and it took a lot of effort from the programmer side just to make sure things were running smooth. So to help all that, or to help ease with that process, the developers at Android came up with something called Room. And Room is a library that helps map classes in Android to tables in SQLite. We'll see what this means when we look at the Codelab. You start off with something called data classes, which are you can think of as objects or classes in Java. And one advantage of data classes over the classes in Java is that when you define the variables or the properties of the class, getters and setters are automatically created. You don't have to specifically or explicitly create them. If you annotate the class keyword of the data, this will happen automatically, and you can use this methods as in you would normally if you explicitly declared them. So with context of Room, data class is marked with something known as an entity keyword, and when this is compiled, when the code is run or bundled up, Android understands that this is a entity, and it basically creates a table with these files, with these properties as rooms. And entity represents a table in SQLite, and query is a command that helps you access, update, delete, or insert data into a database. You can do much more than these with the complex queries, but we won't look into that for now. Another component of the whole database thing in database concept in Android is DAO, which stands for Data Access Object. And as the name suggests, it's an object that lets us access data. This is a class that contains the functions that are essentially SQL queries that help you manipulate the data in your room database. And there are a few standard queries for inbuilt methods such as insert, update, and delete. These are pretty standard queries. So Room has some inbuilt methods for them, and we can directly use those methods instead of writing the SQL query for them. So that's it for Codelab 1. Now we'll go through it and see concepts we talked about, put into action. So like I mentioned, we'll be building the Track My Sleep app from the existing repo here, so you can download that when you're doing it on your own. So the first step in this Codelab is to create the sleep night entity. And like I mentioned, entity basically represents a table in your room database or SQLite database. And in the world of Android, it's represented with a data class. So here you can see this is the code given for the data class. This is how it's declared. As you can see here, you have nothing, you don't even have a body for the class. You just have one line, or essentially one line, or just a constructor type of thing. You have this is for people who know Java, this would seem familiar, especially with the class keyword. What the extra data keyword does is it generates the getters and setters automatically for you. This is a property of Kotlin, not Android. So you can use this in Kotlin projects as well. And here you would declare all the properties that you would require to initialize when you're initializing an object of this class. And that's as far as Kotlin stops, like as Kotlin goes. Sorry. Now from now on, we'll be looking at Android. So with the add room library, you can annotate any class with something known as entity. That is a key. You can think of it as a keyword. And what this does is it maps the data class to tables in your room database. So when it's compiled, Android knows that this data class with its properties represents a table and creates a table. You can even give the table name in the along with the entity, and it will create a table name of this name with these properties as columns. Now, primary key is a concept related to SQL. What it basically means is that every value in that row has to be unique. If you try to insert, let's say, let's look at the AMS example again. I said that they probably have a couple of columns, one of them being student ID. So obviously student ID has to be unique. Two people can't have even if they have the same names, two students can't have the same IDs. And one way to do it is randomly generate student IDs, and that would be it. Won't have to worry about duplicates, but even then there is ever so slightly of a chance that you get the same value for two students with respect to the ID. So what you can do to prevent this, and if you don't do anything, if you leave it as it is, SQL won't take any measures on its own to make sure that you have unique IDs for a certain column. You have to tell it specifically that, okay, for this column, I only want unique values. People shouldn't enter duplicate values. In that case, you use something known as a primary key. You can declare one of the fields or the columns in an SQL table while creating it itself as a primary key, and SQL understand that, okay, this values in this column should not be duplicate. If they are, you'll get an error while inserting the entry saying that the row with this key already exists. And this primary key, because it's unique, it's helpful in other ways such as deleting or updating rows. You wouldn't want to update multiple rows with the same ID by mistake. One other thing is, like I said, you can generate the Even if you have a primary key, you can still generate the ID randomly. And if you by mistake generate ID that already exists, you can just try again and get a different one with a random generated and use that. Another option is you can use something known as auto generate, which basically you can set the first value for your first row. So if I say that the first value for the student ID should be 1, every time you enter a new record, it will increment the value from before. So it will go on 1, 2, 3, 4. You don't have to take care of this. And you can even set where the starting value starts from. You can set it from 1000, 1, 200, it's your choice. So that's what this line is here. We're setting the night ID property of the sleep night class to be a primary key, and we're saying auto generate equals true. If you don't do this, you'll have to take care of assigning the IDs yourself. And in the case that you forget, you get an error saying that this isn't an ID or something like that. And your insertion won't go through, and with respect to the app, it will probably crash, which is not good. So to avoid that, you can just set this property true and leave it be, and you don't have to worry about that at all. So this is some of the other annotations you can use, like column info. You can just set the name to it. If you don't, Android will still split it up like this with underscores between each word if you use a camel case. But if you still want to specifically mention it, you can. There's no harm in doing that. The next step in this task or in this code lab is to create the DAO. And like I mentioned before, just a quick recap, DAO is a data access object. And this is the class that provides all the methods for inserting, deleting, updating, any other manipulations, any other things you want to do from the database, either to get data or insert data or to update data, any form of them. So here, this is what I was referring to, that Room provides inbuilt methods for standard queries. So for insert, update, and delete, there are standard structure syntax for SQL queries that you would usually write, and depending on the number of columns you have or the table name and things like that, even small operations like this could require large queries. So to avoid all that, what Room does is it gives you a couple of standard annotations to carry out these inbuilt or standard queries. So insert obviously refers to insert and update refers to update. And the other inbuilt annotation is delete. Unfortunately, you don't have one to get all the data and display it. So for that, you'll have to write your own. And that's where the query annotation comes in. What you can do is you annotate one of any method with a query, and you, in brackets, you put the query you want to. And underneath, if you put a method, when you call that method from anywhere else in your code, this query will get executed in the Room database. So as you can see here, they have a function called getAllNights, and the query they've attached to this function is select star from the table name by descending order of the nights, which is what the syntax for selecting all the records from a table in SQL is. And this is just to create the database and actually create it and test it to make sure that it works. So you'll get some, once you run this code that is given this task, you'll get some messages in the console and you can test it. There is another proper way to do it. I will share that with you guys in the group after the session. You can do a small activity you can save where you can actually download something known as SQLite browser, and you'll generate some files once you run the database, or once you actually perform some action in the database, you'll run it. And once you upload those files in the browser, you can actually see your database table and the data in it. So once it's done, once the session is over, I'll give you instructions also on how to do that and give you the required resources as well. So that's it for the first code lab. We look at the next ones. Okay, code. They're threads. They're much better than threads. They can be suspended. They can switch context easily. They won't lock the main thread. They're asynchronous. And are you confused? Did I say too much? Right, so I did this on purpose. Coroutines can be very confusing if you don't know anything at all, even about threads. Let's take a couple of steps back and see if you can actually understand it from a better perspective. So the first thing to start from, the first concept to look at is threads. Basically, in a normal program or standard program, commands are executed sequentially. So if you take a look at this program here, you have four statements. One is to print hello world, one is to initialize a variable, the third is to square the variable, and finally it's to print the value of the variable, which would be 9. In a standard program, all these programs, say instructions in the program are code statements or lines in the code, would get executed one after another. So print hello world would happen first, then the initialization, then the multiplication, then the second printing. But And thread, basically what it is a block or level of code. It's just a separate piece of code that you can think of it as a box. It's its own thing, it's its own place, or it has its own selection or region defined to it, and execution of any of the code in that thread happens there itself. Usually all the commands in a standard program run in one main thread. So like I was talking about this standard program here, it has its one thread, its one main thread, which is where all the stuff runs. Since it's a standard program, we haven't done anything yet to make it two threads. That's where the concept of multi-threading comes in. You can actually introduce multiple threads in one program. And what happens is the commands in these two threads run at the same time independently of each other. They don't have to wait for one particular command to finish in the first program to start running the second command in the second thread, or vice versa. There's no dependency on either of the threads. They'll run on their own pace, on their own time and memory. And because of this, you can't predict the execution. You cannot say that, let's take a look at these two threads. You have, this is basically the same one for the main thread example. And this is the second. So if you run these two codes on two threads in the same program, you can't really say which one will happen first. You don't know if you'll get hello world first or hello world from thread 2 first. You don't know if x in this will be initialized with 3 or if this will be initialized with 2 first. This is because they execute simultaneously, and as and when they're done and if they have any result to print, they'll print it immediately without waiting for any other threads, which is why they're independent. That's what threads are. So what? We learned about threads. So what's the point of why even bother learning about threads? Well, let's look at a couple. Let's look at why. Android has one main thread, just as any program does. If you take any Java program, Python program, C, Kotlin, even Android Studio project, one of the main classes, they all have one thread. And usually, at least for Android, the convention or the standard practice is that the main thread includes all the URL related code. When I say URL related code, I mean showing the components, handling the click listeners, and maybe getting some data. Suppose you have an input field or a text field on one activity, and you want to get the text that was there after the person hits a button or after they exit the field, or if someone selected an option from a dropdown, you want to see what option selected. Getting all that information is also related with UI. And UI refreshes every couple of seconds. It's what something Android does, and it also refreshes on updates. So this all happens on a normal basis. And normally on a standard app, or at least on the apps we've been doing till now, that's fine. Let's think of one situation. You click on a button, it takes you to a new page, and UI is loaded, right? Actually, we've done that for the trivia game app or for the charades app. We've done that. You click on next, and it goes to the next page, and the UI is loaded. That's completely fine. But what if the button you're clicking is supposed to load 128 MB of text from a server or from some other data source and load it as UI on the next page? This is just a pseudocode I've written. You create the view, let's say it's a fragment, right? So you create the view and you get data from the server, then you load the UI. So that's the normal case. And if it is maybe like a couple of KB or even 1 MB or something, it will be fine. It's not that large compared to 128 MB. It'll load the server and it'll load the data from the server, and with the data, it'll populate the UI. what if it's 128 MB? In the main thread, since it's sequential, what would happen is that the UI would have to wait for the server, this get data from server to complete execution, store the data, then the UI can load. What will the app do till then? It has to do something, right? You have to be shown something when you move to the next page. You can't just be shown a void or a black screen. What happens if it takes too long? What if the app, the call to the server takes too long? Your app will crash, or in other words, your UI will lock up because it doesn't know what to do. It's not being loaded yet, and you press the button. What's going to happen? And in that case, your app will crash, and that's not going to look too good. This is why we have threads. So imagine instead of doing this, I ran the get data from server to on another thread, and in the meantime, I loaded the UI. So let's say I'm showing list of all the movies from the past 20 or something. So while I'm waiting for the server call to finish, I can show some spinning image or or a progress bar or something saying it's loading. And when the get data from server call is done and it's loaded, then I can show the populate it with the UI instead of having my app crash. That's the very fundamental concept or principle of use of threads, and we do this often in Android. We either call from make data calls to the server, or we load something from room database, something other we're doing that's not just with static data or with program created data. So it's very important to have a concept to have a good grip on the concept of threads. And as we go see further coroutines as well. So this is the main use for threads. This is another thing to know, synchronous versus asynchronous tasks. Let's see what they mean. They're very similar to what the stuff we've just discussed in now, but I thought I'd put it in here since they're a common term too that comes up when talking about threads or coroutines. And I thought it'd just be nice to let you guys know what it is. Synchronous basically means only one function can be executed at a time. It's dependent on one other functions, and they wait for one function to finish executing before they start executing themselves. So as you can see here, two synchronous tasks are there, so they go hand in hand. Task 1 always has to be up to date with task 2 status and vice versa. So in this case, task 1 is above task 2, so task 1 has to finish, and task 2 has to keep track of task 1 progress, so that when it finishes, task 2 can start executing. This is what synchronous means. They're dependent on other functions and have to wait for one to finish before they can start executing themselves. Asynchronous are completely different, they're polar opposite. Multiple functions or multiple asynchronous tasks can be executed as once. They're independent of the other functions, and they don't have to wait for one function to finish before they start executing themselves. As you can see, compared to the previous picture, there are no relation between task 1 and task 2, doesn't exist, and they can execute on their own plane or time. So we talked about threads, then what's coroutines? Why did I start off the second concept with coroutines? Well, coroutines are lightweight threads, and they have certain advantages over threads, and this is something developed by it exists in Kotlin also, it's a Kotlin concept, and it has some advantages over threads. Coroutines can be executed within a thread, so you can start multiple coroutines within a thread or in multiple threads also, and they can be suspended as well. Basically, if you start, let's say, 1,000 coroutines in one thread, you can suspend a couple and then resume them again whenever you want, based on the code you write or based on when you want. Maybe you pause coroutine 1 until coroutine 10 is done. So when coroutine 10 is done, you can say that you can start coroutine 1 again. And they can even switch threads. So let's think of coroutines. Let's think of a situation to help us understand this better. Let's say you have two threads, and let's represent them with construction sites, and let's represent the workers in both construction sites as coroutines. So you can tell one of the workers to take a break, and then pick up when some other worker starts to take a break, or when the other worker leaves. And you can even tell the workers to switch over from one site to another site. So that's what coroutines are. They're lightweight threads, and they have the same principle as threads, that they're asynchronous and they don't have to wait for others. Before we continue, let's go back to the previous slide and see if we can understand this better now. So like I said, they're much better than threads. They can be suspended, which means they can be paused until further notice. They can switch context. Context basically mean it's the situation or the thread in which you're running. It's your own bubble, you can think of it. So like I said, you can think of contexts or threads as those two construction sites, and they can switch between them easily. And it won't lock the main thread. Lock or crash or freeze or suspend, like we looked at in the reason for thread slide, that won't happen when you use coroutines. And they're asynchronous, obviously. They can run on their own and they don't have to wait for anybody else to finish before they start. In order to use coroutines, you need a couple of things, and they are as follows. You need a job, which is basically assigned to a coroutine, and you can cancel coroutines through jobs. So if you cancel a job, or if you stop a job, or if you can use a job to cancel a coroutine, you can have a hierarchy of jobs. You can have parent jobs and children jobs. And as you may guess, if you kill the parent job, all the children jobs get killed too. And there's something known as a dispatcher, which is what actually helps run coroutines on different threads, and it's what you can use to switch coroutines as well between threads. Lastly, you need something known as a scope, and it's the context. It has the details about the context or the thread or that small space or bubble you can think of in which the coroutines run. So it will also work with the dispatcher hand in hand to make sure if you need to switch between threads, if you need to switch a coroutine from one context or one thread to another, this is what helps as well. Now let's take a look at Codelab 2. So we'll be building upon the sleep tracker app from last Codelab. If you want me doing this, you can continue with the project you've already started with from the first Codelab, or you can download the uh, improved version of the code from GitHub at the beginning of this Codelab. So with keeping in line with our app architecture concepts, will be as this first task is to add a view model for the sleep tracker app. And it's just updating all the code we've done so far with respect to the the view model to make sure all the things are in that line of modularity and readability and maintainability with respect to MVVM pattern. Then we'll be adding data binding, which is something else we looked at last session, and it helps you remove that extra connection between the fragment class, the layout in XML, and the view model. Then this talks about coroutines as well. This is just a recap of what I talked about in the slides. You can go through it again. And the last one is using the DAO to collect the data from the database and display it on the screen. So here they've shown a quick comparison between what would happen if you use room or without room. So this could, if you understand the code properly, you'd be able to appreciate the room even better. Yeah, quickly dispatcher. Some of the dispatchers, there are many dispatchers you can use with the room library. Some of them are dispatcher.main, which runs the task on the main thread, and dispatcher.io it basically has the input output devices and things like that. And there are a couple of other dispatches you can search on about yourself. So that's about the second Codelab. The third code have any concepts. It's all just using what we know before itself to build upon the app.
First thing we do is add navigation, which is what we looked at in the beginning of track 2, which is another way of essentially replacing intents or activities with fragments. And I won't go into that now. That's not the focus of this session. If you want, you can rewatch lecture from that time or go to the particular pathway. Next thing is creating a view model again and a view model factory to record the sleep quality, which is another part of this app. And refactoring the code to make sure it all works with the current changes we made. And adding a snack bar. A snack bar is something, it's like a pill, it's like a toast, but actionable toast. You can perform some action on the snack bar and it pops up at the bottom of the screen. So maybe you've seen in any notes app or something like that, if you delete a note, you can get an option that says undo. So that's what a snack bar is. That's what usually snack bars are used for. If you want to notify the person of anything that's been done and you want to let them take action, either to, in this case, undo, delete, or let it go, you can use a snack bar. Now we have a couple more things looking at other Codelabs. Recycler views. This is, if for people who've been here since track 1, this is just a review of it, so please bear with me. I've put this in for people who are new to the program. Recycler views help you display lists in Android. Think about, you can think about gallery. It's essentially a list of a collection of photos that are being displayed or pictures that are displayed in the app, or even chat lists, call logs. Even the alarm app has lists in that it shows you the number of collection of alarms you've set with certain properties and a certain UI for each of them. Notice that each alarm here has a fixed UI. And we'll look at that later, it's important. And it's one of the most common UI components. As you see, if you have a large data, which is common for almost all apps being used today are real world apps, you'll want to display it. And if you want to display it, one of the common ways to do it is app lists. So in that sense, it's one of the most common UI components. And Recycler view helps you do this efficiently. We'll see why it's efficient. It's efficient in the sense that what the Recycler view does is that it creates view holders. As the name suggests, it's something as an object or a container for a view for items in the list and reuses them as the current item is scrolled off screen. So let's say in this alarm app, let's say you have 10 or 20 alarms. So obviously they all can't fit on the screen. Let's say only 5 can fit on the screen. So what Android will do is it will realize that your screen can only fit 5 alarms at a time and tell Recycler view to create only 5 view holders. And it will display the first 5 items in the list in these 5 view holders. When you scroll, instead of destroying the view holders and creating new ones, it will keep those view holders in place and it will load the below items. So it's efficient in that it doesn't create 20 view holders and load them with each and every new item in the list. It's that it loads a couple of view holders that can fit on your screen and load the new views, just the items and not the view holders themselves. So as I said, it creates view holders for as many items that fit on the screen. Let's look at the parts of a Recycler view. First off, this is the whole Recycler view. This is the app that we built for track 1. Discuss that. So as you can see, it's an affirmation app. It can a picture and a to go with that. And this is a view that you can think of is like a container. Think of a view as each item in the list. So view usually means a UI component, and in this case it means the whole page as well as each individual item is a view as well. The view holder holds the view. It's a container, as an object. You can think whatever you want, but it helps you think of it in a bigger. That's a simple container that lets you hold or display a view. The most important thing is that each view in this particular layout, it's fixed. you see here that each item contains an affirmation text. And if you go back to this alarm app, you see the item whether it's PM or AM, the number of days it should ring on, and whether or not it's switched off. So that's each alarm item has this, and that's how you design a layout as well. It's not that you create for these items, you create Android loads them as and when required and applies the same layout for each new item that you're loading in. This is as far as implementing recycler view goes. Create the layout for each item. It will be referenced later on to fill in the view and provide the data. In your recycler view to the activity or the activities layout, like you would do with any other UI component in a layout editor. And you create an adapter, which is a class that helps you transform data to display in the list. So if you have, in the case of the affirmations app, you just have links or parts of the images and text. You can't display it like that. You can't display it raw. It wouldn't look nice and wouldn't make much sense. Similarly, for the alarm app, you would just have the date or list of days, a button state with a true or false variable or a Boolean variable, and the time. You can't show that just as it is. It's raw data. People won't understand anything, and it'll be very difficult to comprehend. So the adapter helps you transform this data to display in the list. Like I said, it creates view for each items. So Android calls the adapter when it wants to do this, and it does it in the efficient way, like I said before. And it's called by the recycler view, and it also provides the data. So you can think of all the data you need to display as in a list. So adapter will automatically understand the position of each list, and based on the position, it will load the corresponding data. Lastly, let's look at the adapter a bit. You'll be given the list of items to be shown on the screen as well as the activity context. Context basically contains details about the layout. And what happens is it creates a takes in the view and references UI components in the layout you built for each view. And with the view holder comes two functions called onCreateViewHolder and onBindViewHolder. What onCreateViewHolder does is inflates a view with the layout. So once you create view or take in the view, whatever layout you've decided to use for this particular list or for each item in this list, you inflate it with that layout, that particular view, and you return a view holder with the created view. So you got the view holder and you got the layout. Next is providing the data, which is where the onBindViewHolder comes in. For a specific item or a specific view in the list, it provides the data to be filled up, and that data is put onto the existing view holder with the layout. Once that's done, at the end product is what you have that on what you see on the screen. It's a displaying list of app on the app. Here's a quick summary again of displaying lists in Android. You have recycler view which displays lists. Each item in the list is one view. Each view is contained in a view holder, and the view holder needs the view layout and the data. And this is created on the recycler view's request. This comes with two methods: onCreateViewHolder and onBindViewHolder. onCreateViewHolder provides the layout, onBindViewHolder provides the data. So we look at the fourth Codelab. So they talk about the same concept that I just went over. This picture should give you a more clearer explanation or clearer view about what I meant with the efficiency of the recycler view. So think of it as two fixed slots here. So you have 1 and 2, and those are fixed holders, and you're just loading in different views as you scroll off the screen. So that's where the efficiency comes in that it doesn't create as many view holders as there are items in the list, rather as many view holders that can fit on your screen with respect to the size of each item or each view. So this task is just to implement a recycler view and add an adapter. Once you go through the code, once you write the code yourself, you understand with respect to what's going on written in the code and the explanation I've given, you should be able to understand pretty easily. And the good thing is, once you understand well enough what the actual code does for the adapter, you can copy it for any project you want to use, and all you'll have to do is end up changing a few things. it's generic in that way, and pretty much everywhere you go, any code you write, you'll have the same requirements. So all you need to do is change a couple of things and you can keep the code the same. So here what they've done is you can add a little extra code to see how it's actually refreshed or recycled. Here you can see there are only a couple of the items far apart are in red, so that's how it recycles it. So this goes on to add the recycler view for people who've already attended all the sessions for track 1. You can mostly skip over the explanation in this code lab. You can just read the code and try to read the code yourself also. And this is just doing some code refactorings to make sure your code is cleaner and shorter and doesn't have to be as long as it is already. And similarly, just like for Codelab 3, there's not much of a concept to talk about for Codelab 5. There are a couple of things, but I felt they weren't big enough or complex enough to include in a slide, so I'll explain them as we go through them, encounter them in the Codelab. So often what happens is, let's say displaying a list of students, or let's say displaying rather a table, excuse me, with a list of students and their marks. And let's say one of the students found something wrong in their mark for a particular test and they want to get it changed. So you change it and you have to update it in the page. What you can do is with recycle view, you can do or you call a method that's known as notify dataset changed. So what this does is it'll once wherever your data source is, in this case it'll probably be in the database. So when you update the marks in the database, since this recycler view is essentially attached or connected to the database, whenever this happens, you'll get a notification, or the recycler view get a notification that something is changed. And when you implement that method, the notify dataset change method, it will notify the recycle view and it will change the set automatically. So, and when you refresh the screen, or normally if you'd have to refresh the screen to save the difference, but if you're using LiveData, which is what we discussed again last week, you can see the change instantly. With the normal procedure, but there's something more you can do extra. Suppose you have a list of 110 students and only a couple of them want to change their marks. Would it be better to reload the whole list or the whole data again just because a couple of them changed? Or would it be nice if you had a method where you could, or a procedure or something to do that you could, or who has the information change? Or maybe what you could do is you could load the new list, compare the old list, see the differences, and only incorporate those differences in the already existing list. So you don't have to load all 110 people again, as that would affect your performance. This is exactly what diffutil does. What diffutil does is whenever data changes in the recycler view or the list you're displaying the recycler view, it takes a look at the old list, takes a look at the new list, looks at the differences and only loads those differences in. So you can see here that we're returning in one of the steps for implementing this diffutil process, we're comparing the old item and the new item, their IDs and Boolean values, and based on that you can display or use the diffutil to see if anything is changed. Alternatively, you could just compare the whole item, and if there's even a single property difference, you can use the diffutil instead of loading the whole thing. And this is just extending the recycler view code further. And you can use data binding here as well. So previously we used data binding to handle button clicks or click listeners or event listeners. You can extend that concept to
recycler views as well. And binding adapter is just a shorter way or another extension or a variation of data binding and recycler views. It's kind of a combination of both of them. It's not too difficult. It's basically taking two things you already know and getting you the best of both worlds. You can go through it in more detail in the documentation. And that's it for Codelab 5. So this next Codelab actually ties back into something that was talked about previously as well. So in the first track, I talked about layouts, and even in the beginning of this track, as a recap of track 1, I mentioned layouts, which is basically the shape you give your screen or activity and you decide how it looks. Couple of layouts that already exist that are standard in Android are table layout and linear layout. So table layout, if you declare that your layout or activity will be a table layout in the XML file, you essentially restrict positions of your UI components. You can only place them as you would place them in a table. So only in rows or columns you can place them. You can't place them anywhere you want, which is the case with other, if you take a constraint layout, you can place them anywhere, but you'll have to constrain or fix the sides of each layout to other parts of the screen. And lastly, you have linear layout, in which you have two further types, horizontal and vertical layout. So if you choose horizontal linear layout, you only have to place the UI components horizontally one below another. And if it's vertical, you can place them next to each other. And if you look at the gallery app and chats in WhatsApp, both are lists, both are displayed using recycler views, but you'll notice something different. In WhatsApp, you have the chats one below the other, and in sorry about that. So like I was saying, if you go back and look at the code for recycler view, and while setting it up, you'll see that you come across something as layout manager or so what this is, with using the select layout method and the layout manager object, you can specify layout type that your linear recycler you will have. So if you use linear layout or a vertical linear layout, you will get what you have in the WhatsApp chat list, which is one below the other. If you use something different, which is what this uh, Codelab is about, if you use a grid layout, they'll appear one next to each other. As you can see, appear next to each other. And you can even set the amount of span, or basically a amount of items that each row should have. You can, if you set it to 3, each item will have 3, or if you set it to 2, each item will have 2. That's your choice. And obviously, you'd have to adjust your size of the view as well, depending on the number of spans or items you want to have per row. And if you don't do that, it will automatically resize, and it might not look good based on the amount of data you're showing. This task is just implement the grid layout, which is not too difficult. It's just changing one line of code. Yeah, so here you can see a grid layout manager, and even here you have two types, horizontal and vertical. It's not a big concept, but it's just something to know exists. So in case you want to change a layout or you wish for a better layout, you know that this kind of thing exists and you can quickly change it with this knowledge. And Codelab 7 as well. This ties into extends the concepts of click listeners or event listeners. Basically, last recycle review we just show the items and there's no interaction between the items that the user. You could not happen in click items. This is what this Codelab changes. So just to the app we're building, in the Track My Sleep app, you'll have each night or each day as one item in the view. If you click on it, you can get more details about the particular night. With the absence of that, the items are unclickable, and when you add that, the items become clickable, and you can add the corresponding code.
So here again, there's more data binding done. So again, data binding, what it does is instead of having to initialize something, a UI component in the layout editor, and initializing that particular object in the code, and then setting a quick listener from there, if you use data binding, you can directly implement this click listener from the XML file itself with this such syntax, and that removes another extra layer of connection or dependency between the components in your app. So what this does is, what we're doing here is in this Codelab, we're starting off with the interaction between each click or each item click in the list. So when you click a particular item, you're showing a toast with the corresponding night ID, the ID of the night. This is done to show that what would happen if it works, or if you have the code properly, is that for every item you click, you get a corresponding night ID, and won't be the same static text for all of them. Next is to handle the clicks. Up till now, we just showed the post and you click, doesn't do anything, and now is to navigate to another page and that page with the data you get from the click. So it will be different for different nights, and that's what this is done.
Survive.